Okay, welcome back, class. And today we're going to continue on with using the simplex method and start applying to maximization problems. And what we're going to do is we're going to basically start where we left off before, because last time we started, we talked about how to set up a initial simplex tableau. Now we're going to basically go from there and see how we maximize, and the process of going, how the simplex method goes from point to point to point, and shows you what the maximum point needs to be. Okay. Oh, why isn't it working? Oh, there we go. Okay, so in the previous section, we showed that how to prepare a linear program problem for solution. So what we did was we converted the constraints to linear equations, and we did that by adding slack variables. We used the coefficients of the variables from the linear equations to write an augmented matrix, including the objective matrix. And then we used the pivot to go from one corner to another corner point in the region of feasible solutions. So what we're going to do is we're going to use our example. I think it was example 1 in the last section. And so now we're ready to put this all together and produce an optimum value of the objective function. So if we go back to this example here, this is what we had. So these were our two constraints, and this down here is our objective function solved equal to 0. So this is our z, and these are the coefficients, and they're negative because we moved them to the other side of the equation. But this was our augmented matrix. And we also talked about the basic variables. So in this case here, S1 and S2 are the two basic variables. These are the ones that are going to be non-zero, and the rest of them are going to be 0. So all of these go to 0, and then S1 and S2, so all we get is basically, well, and S1 and S2 are 0. So we basically get the conclusion that, well, if you don't plant any crops, you don't get any profit. Okay. So the tableau leads to the solution, which is what we get here. Okay. Where S and 1 are the basic variables. Now these variables produce a value of 0 for z, as I showed you. Now this is not surprising, since obviously 0 acres produces 0 profit. Now there's got to be a better option. So how do we find out what the other alternative solutions are? Well, this is where we go back to the objective function. And we notice here that the coefficient 120 is the largest. So we would say that, hey, this has the biggest impact on profit. So it would make sense that if we say, hey, why don't we improve this? Why don't we make this bigger and see how big we can make this to make the profit improve? Okay, so to determine how much to increase the x1 by, we look at the constraints again. And now in this case here, because there's only two equations, we can only have two basic non-variable variables, non-zero variables. Okay, so now if we're going to increase this one, then we want x1 to be a non-zero variable. So now before we had x1 and x2 be were the non-zero variables. Those were the basic variables. So now one of those two variables now needs to become non-basic. So how do we decide which one is going to be non-basic? Well, what we do is we look at, oh, hold on a second. Before we do that, I'm going to back up. So here, let's start with this one being non-zero. We'll deal with the other two in a moment. But let's say this is the non-zero one, which means these two we're going to make 0 because we're only focusing on this one. And so our two equations reduces to this because x2 and x3 are 0. Now we get these two sets of equations. So these two reduces to these two sets of equations. Okay. Oh, in fact, I messed up. This should be a 10 here. This should be a 10. Hold on a second here. Oops. Okay, this should be a 10. There we go. Okay, so now the first equation implies that x1 cannot exceed 100, and then in the second equation implies that x1 cannot exceed 50 because we have to divide by 10 on both sides. So now that means that x1, if you look at both of them have to be correct, so that means we have to take the smallest one. So x1 cannot exceed 50. So now, if we let x1 be the maximum it can be, 50, then what does that mean? It means s1 has to be 50. And so s1 is going to be our other basic variable, which means s2 is no longer basic. Okay. Now, having replaced x1, or replacing s2 with x1, we get this. Okay, now when we look at this, okay, we see that x1 is a variable, or excuse me, x1 is the basic variable, s1 is the basic variable, and so we can use this to solve how much we can do. Now, we could have done this with the tableau and arrived at the same conclusion. Okay, now if these two are 50, if this is 50 and s is 50, well, what do we get? Well, we get, if we go back, if x1 is 50 and the rest are 0, right? So this is 0, this is 0. Well, these are both going to be 0. Okay. And what do we do? Well, what did we do here? Well, we started with what? When we look at the tableau, the initial tableau, what do we get? We saw this number here, right? Now remember, these values here are the indicators, right? So we started with the 120, the one with the largest coefficient, but in this case, it's the one that has the largest negative value because remember, we moved all the variables to the left, and so these all became negative. Okay, so this one, this most negative value is the one that we're going to start with. Okay, so that's the first thing. Okay, now to determine which of the basic, now again, we know which one turned out to be which one became non-basic based on our analysis. Well, let's see how it works with the tableau. So we look at this one, right? So we're looking at this column, we're looking at x1. And now to decide which one of these two are not going to be basic anymore, well, we take the coefficients of these two and we divide these two by them. So we forget about this, ignore this last row. So we're only looking at the constraints, remember? So we're going to divide both of these rightmost numbers by the coefficients. Okay, so when we divide both of these by the coefficients, what do we get? We get 10, 500 divided by 10, which is 50. We get 100 divided by 1, which is 100. Well, which one is smaller? Okay, Well, the one that's smaller is the one that we're going to use as our pivot. So in this case, the 10 is going to be our pivot. So now what we're going to do is we're going to eliminate all the rest of these numbers in the column by using elementary row operations. So now once we use our elementary row operations to eliminate those two, now we end up with this matrix. And notice that now these are 0. Now look at the rest of these. Notice that over here, these were the two variables that were the slack variables, and they were both basic before. But now look, this one here has 10, 0, right? So it's 10, 0, 0. So notice that the only one that has a non-zero value is this one. So that means S1 is going to be the other basic variable. And so S2, the rest of these, X2, X3, S2 are all 0. Okay, which means that once we look at this here, what happens? This is 0, right? So 0 times this is 0. 8 times X2, but X2 is 0, so that's going to give us 0. 24 times X3, but X3 is 0, so that's going to give us 0. And then we have what? S1, and S1 is non-zero, but the coefficient is 0, so that's going to be 0. 12 times S2, but S2 is 0, so that's going to be 0. So all of these give us 0 terms except Z, which is 1. And so Z equals 6,000. Okay, so the answer is 6,000. Okay? Now, any questions? Okay, good. So here's what we're going to do now. So we've got an answer. So that means we've got at the next point, okay, at the next point or the next corner, the profit went up from 0 to 6,000. Okay, so there's our answer. Okay, so if X, right, is 50, as we saw before, then and X2 and X3 are 0, then the maximum profit that we get is 6,000. Okay. Okay, now notice all the indicators in the bottom are positive. Okay. That means that the objective function cannot be improved beyond $6,000. As long as there is a negative indicator, the objective function may be improved. So what we do is we go from the most negative and we do our pivot. We choose our pivot, and then we simplify the matrix, right? We get rid of the zeros in the column with the pivot, okay? And then we look at the objective function and we see what the value is. And then if there's another negative at that point, when we look at the new tableau, if there's another negative number, or if there's more than one negative number, we take the next larger negative number, and then we choose the pivot in that row, or excuse me, in that column, and we do the process again. And we do this until we don't have any more negative numbers. And then once we don't have any more negative numbers as an indicator, no negative indicators, right, which is in the objective function, then we're done. And whatever value that's in there is going to be the maximum value, the optimized value. So here are the steps for the simplex method for the standard maximization problems. Okay. So now, 1, determine the objective function. 2, write all the necessary constraints. Okay, 1 and 2 we've been doing. 3, convert each constraint into an equation by adding a slack variable in each. We did that in 4.1. 4, set up the initial simplex tableau. So 1 through 4 we've done in the last section. Now 5 says locate the most negative indicator. If there are 2 such indicators, choose the one farthest to the left. 6, from the necessary quotients, right? Remember, we're dividing the numbers, the coefficients and the constraints, and we're taking the coefficients in that column and we're dividing the rightmost numbers, right? Okay, it says form the necessary quotients to find the pivot. Disregard any quotients with 0 or a negative number in the denominator. Okay, so remember, we don't want to use negative numbers in the denominator or 0. Okay, the smallest non-negative quotient gives the location of the pivot. If all quotients must be disregarded, no maximum solution exists. Okay, let me see that again. Let me say that again. If all quotients must be disregarded, no maximum solution exists. Okay? If 2 quotients are both equal and smallest, choose the pivot in the row nearest the top of the matrix. Okay? And then 7, use row operations, elementary row operations, to change all of the numbers in the pivot column to 0 by adding a suitable multiple of the pivot row to a positive multiple of each row. Remember, we're not taking any negative multiples of the pivot row. Okay? Positive multiple. We take a suitable multiple of the pivot row to a positive multiple of each row. Okay? If the indicators are all positive or 0, this is the final tableau. If not, go back to step 5, repeat the process until a tableau with no negative indicators is obtained. And then 9, read the solution from the final tableau. So in this case here, you're just doing the process over and over and over again until you don't have any more negative indicators. And when you don't have any more negative indicators, you look at your objective function, and that's going to be your optimum value. In this case, your maximum value. Okay, so now to compare the simplex method with the graphical method, we use the problem we used in 3.3. So the graph is shown again in the next slide. So the objective function, which was revenue, was maximized to this. Okay, so that's okay. So z equals 25x1 plus 30x2. Now notice that instead of using x and y, we're using x1 and x2 now. Okay, now I'm going to jump out of here for a second. And let me go here. Okay, so notice, I'm going to make this bigger so we can see this. Okay, so here's the example. I didn't want to write all this out, but notice that they have this here. Okay, so now here are all the constraints that we had before. And what we're doing is we're going to change all of these to equations, and we're going to add a slack variable to each one of these. Okay, so here are the 2 constraints that we're going to use. And so we know that x1 is greater than 0 and x2 is greater than 0. And so the initial tableau is going to be this. Now notice that we're going to add the slack variables to these. So we're going to add these two inequalities. We're going to make these equations, and we're going to have S1 and S2 to both of these. So now our first inequality becomes our first equation, which is this. Our second constraint becomes this equation, and so we have the two slack variables. And then of course we have to add the fact that this is positive and this is positive, which was given to us, but also S1 and S2 are also greater than or equal to 0. And now using these two constraints, we set up our tableau. And then now, this one here is the most negative value. So this is going to be our pivot column. And so we take this number here, we divide 300 by 5, and we divide 65 by 1. Well, 65 divided by 1 gives us 65, and 300 divided by 5 gives us 60. So that means this is the pivot row. So this negative number gives us the pivot column. This gives us the pivot row. So now our pivot is going to be 5. See how that works? And so now we're going to use this pivot to eliminate this and to eliminate this using our element and row operations. And in doing so, we obtain this. Okay. Now, notice that there's another negative number here. Okay. So now we're going to use this as our pivot. Since there's no other negative numbers, this is going to be our pivot. Now what we're going to do is we're going to find the pivot column. And so we're going to do that again. So this is our pivot, or excuse me, pivot row. This is our pivot column. So now we're going to divide these two numbers by the coefficients. 25 divided by 1 is 25. 300 divided by 4 is 75. And so this is the smaller of the two. So this is going to be our pivot. So this is the pivot row. This is the pivot column. And where those two intersect, that tells us our pivot. So now we're going to use this to eliminate the 4 and the negative 1. And we're going to use element and row operations to do that. And so when we do that, we end up with this tableau. And now, since we don't have any more negative numbers in here, our final answer for our revenue function is going to be 1825. Okay, but are we done? Well, let's see. These are our two basic variables, right? So these are both 0. These are both 0. So we end up with zeros here. So we get z is equal to 1825. Okay, now that's what, so basically that's what we're doing. Okay, so there's no more negative numbers, so the optimum solution has been achieved. Now it says create a 1 in column 2 by multiplying 2 by 1/5. Okay, why are we doing do that? Well, because we remember we want a 1 here. Okay, and because we want the variables to be 1s, because what we have to do is we have to figure out what amount of x1 and x2 we need. Well, what we're going to do is we're going to change this to 1. Remember the identity matrix here, right? We want the identity matrix here. These are just slack variables, so we're just ignoring those for the moment. So now divide this whole thing by 5, and what do we get? We get this matrix here. So we get this x1, x2. Notice now these are not basic. These are the basic variables right here. Okay. Notice these are not the basic. These are 0. So these, which is what we want, right? So now we make these into 1s. And now guess what? When we multiply this, right? So now 25 times x1 plus 40 times x2 is going to give us 1825. And so our optimum value is 1825. And that will occur when x1 is 25 and x2 is 40. Okay. Now, each simplex tableau above gave a solution corresponding to one of the corner points of the feasible region. And notice the way it worked. You started at the origin with the initial tableau, and then it moved up to this corner, and then it moved to this corner. And once it got to this corner, we were done because we reached the optimum value. Okay, so let's go back. Okay, so that's what's going on here. Okay, so now in this method, or in this example, it says, okay, a 4-H member raises only goats and pigs. Sound familiar? She wants to raise no more than 16 animals, including no more than 10 goats. Sound more familiar? She spends $25 to raise a goat and $75 to raise a pig, and she has $900 available for this project. Sounds very familiar. Each goat produces $12 in profit, and each pig $40 in profit. How many goats and pigs should she raise to maximize total profit? Okay, so we've seen this one before. We worked on the exact same example from chapter 3. Or no, yes, chapter 3, 3.2 if I remember right. Or no, 3.3. Okay, now, since we're using a simplex method, we use x1, x2 instead of x and y. So each variable will represent, a different variable that we're measuring. Now, we have the following linear program problem, which is the same ones that we had before. So now we have our constraints and we have our objective function. Now we're going to add the slack variables. Now these two we ignore because it's just we're saying that these two are positive, which is always going to be the case in these type of problems. So what we're going to be changing are these three. So we're going to change all three of these into an equation, and by adding one slack variable. So we're going to add S1, S2, and then add S3 here, and we get this system of equations now. And so now by setting up our tableau, our initial tableau, we're going to use these and our objective function. We're going to move both of these coefficients to the left, and so they'll become negative. And so our constraints are now with these restrictions here. Okay. And so now this is our tableau. Okay. So now notice that our initial tableau, okay, this is the most negative value. So this is going to be our pivot column. And then we divide these two numbers, or all these numbers, by the leading coefficient. Well, this one gets divided by 0, so we ignore that one. Remember, if we divide by 0 or divide by a negative number, we're going to ignore it. So we're going to disregard this one. And then this one is going to be 16 divided by 1, which is 16. And this is going to be 36 divided by 3, which is 12. And 12 is the lower of the two. So this is going to be our pivot row. And so our pivot column and our pivot row tell us that 3 is going to be our pivot. And so now we're going to use that pivot to eliminate this one, make this 0, and to make this 0. And so what we do is we do our elementary row operations. And once we're done with our elementary row operations, so see that these are 0. Okay. Now notice that there are no negative indicators here. So therefore, we're done. And we've reached the maximum value. Now notice that here, okay, what do we have to do? Well, we've got x1 and x2, right? And so here we can solve. So this is going to be 4. So this is going to be x1, x2. Now here it says we have a slack variable. Okay. Now to be able to read the solution directly from the tableau, remember how we do that. So we multiply rows 2 and 4 by a third. Okay. Rows 2 and 4. 2 and 4 by 1/3. Okay. Why are we doing that? Because we want to get a 1, and we need to have a 1 here. Okay. So now look what we have here. Now, what are the basic variables here? Okay. So the basic variable is x2 and s1. Okay. The rest of these are not basic. So in this case here, x1 is 0 and x2 equals 12, right? And then z equals 48. And that's our answer. So x1 is 0, x2 is 12, and z is 480 because we got 1 here. So these are 0, right? These don't matter because x1 is 0, so 0 times the 4/3 is 0. Well, these two are 0, so it doesn't matter. These two are going to be going to go away, right? And then this is 0, so this is going to go away. So all we end up is z equal to 480. Okay. And so the corner point is 0, 12, and the optimum value of the revenue is 480. So if you have 0 goats and 12 pigs, you will make a maximum profit of $480. Okay. So now, Excel spreadsheet. So just a couple of things on Excel spreadsheet. I know we're not dealing with Excel spreadsheets, but I think it's important to just see how this works. Okay. So this is called the solver parameters. And you can go on here again and find a max, so you can add in your target cell. So when you do a pivot, you pick your target cell. You're going to pick what you're going to do, your maximum, and you're going to by changing the cells, these cells, okay? And then these are the constraints. But we're going to do that in our calculator, and I'm going to download a program onto your calculator when we get to this chapter where you're going to be able to do this on your calculator. So we're not going to be using Excel, but we'll definitely be using your calculator. Okay, and that's it. So I hope this was informative. Please go back and work through the examples on your own. Make sure you understand the process and what's going on. If you don't understand, please write down the questions. Write down where you're getting stuck at, and we'll work through these in class. Work through problems like make sure you're working on the guided notes. Work through some of the problems in the guided notes. If you get stuck, go back to the textbook or go back to the PowerPoints. Yeah, and if you're still not figuring it out before class, bring it up in class at the beginning of class, and we'll tackle it together. So make sure you're watching the videos. Make sure you're keeping up with everything. That's critical to your success in this class. So keep up with the videos. Work on the guided notes before class. Make sure you're watching the videos and you have all the videos watched also before class. And then make sure you're taking notes and writing down your questions. And we'll tackle all the stuff in class and we'll practice. And that's where it's going to make the difference. So until then, have a great day and I'll talk to you later. Bye-bye.